Hello.
Hi, everyone.
Welcome back.
Oh.
I am Astrobit.
I am Major Merger.
We're here for Astronomy in the News.
All right, so first up, this is the moon, in case you didn't know. But according to new observations from NASA's Lunar Reconnaissance Orbiter, the moon experiences heavier bombardment than we originally thought. And this is done by small meteorites that other previous models hadn't predicted. So this implies that the surface features we see on the moon that we consider to be young, due to the low number of impacts they experience, are actually younger. So originally, the lunar surface was thought to overturn at a rate of around 2 centimeters per million years, which is quite small. But now, thanks to a new set of high-resolution images, such as this one, and this is an impact crater with a diameter of around 12 meters, so that's pretty high resolution.
That is amazing.
Yeah. So with new images like this, we found new impact craters around 200 or so, as well as around 50,000 splotches, as they're called, which are just other overturning of the surface, just smaller things from like debris from these larger impacts. So now that it's estimated that 99% of the surface will be overturned by the splotch formation after only about 81,000 years, which is 100 times faster than previously thought. And in terms for humans and what that means for us, this rate means that the Apollo astronaut tracks will actually be gone in a couple tens of thousands of years. So we need to send someone back up there to make some new footprints. And so if you were
fun NASA, please.
Yeah, fun NASA. And if you were with us for our previous talk and we were talking about lunar bases and lunar structures we could build, we might have to make those a bit more durable than previously thought to deal with all these impacts.
Okay, so Bill Sparks of the Space Telescope Science Institute in Baltimore used a Hubble Space Telescope to confirm, or at least give more evidence to, water plumes coming from Jupiter's moon Europa. The first evidence for these was found in 2013 by Lawrence Roth of the Southwest Research Institute down in San Antonio. What Bill did was him and his team looked at Europa as it was passing in front of Jupiter using the Hubble Space Telescope and looking for evidence of the plumes at the edges. Let's see if I can figure out which one's the laser here. Yes, there we go. So this image here is a composite image of Europa. I think it's probably pretty obvious from the quality of the resolution. Here's the a image of Europa. Here's kind of a background image that they've taken. What they looked for when it's passing in front of Jupiter, they look for this stuff at the edge. So these bright spots here is actually, this is inverted color. What they're actually looking for is dark spots as it passes in front of Jupiter. These dark spots at the edge are plumes of water shooting out and blocking some of the light from Jupiter behind it. This is very promising. We've strongly suspected that Europa has an underwater ocean. That's kind of what's shown in the image on the right here is an ocean down here, kind of a thick crust of ice, and then there's these geysers here that are spitting out water. One of the very promising things about this, we'd been contemplating sending a mission to Europa in order to drill down through this giant crust of ice. Kilometers thick. It would be very, very, very tough. This actually is going to be, might actually make it a lot easier to study the oceans of Europa and potentially search for life on Europa. So as this ocean is getting spit up through these geysers, we can actually look at those geysers and see what the water looks like coming out of it, find out what the ocean's like, whether there's salt, whether there's any chemicals that are related to life. So this might offer us a much cheaper, simpler way of exploring the geography of Europa.
All right, so this is the Comet 67P. name I can't pronounce, and Dr. Comet isn't here to help me out with it. But beginning its mission in March of 2004, the Rosetta probe, which imaged this comet, has finally come to an end. Its time with us has come to an end. And minor fail on my part, I forgot to include an image of the Rosetta probe, but I do have this cartoon image of it, which is really cute. But yeah, they posted these videos explaining the whole mission in this cartoon format, which is really fun to watch if you have the time. So Rosetta has been circling the 4-kilometer wide comet 67P for the past 2 years, becoming the first space mission to rendezvous with a comet and drop a lander to its surface, which is Philae seen at the top. So yeah, Rosetta woke up. Oh God, they all came out at once. One at a time, please. Okay, it imaged the comet. Philae dropped. Unfortunately, if you know, Philae bounced a little and landed in the shadow of part of the comet, and so it didn't actually get to do its full job. But it was cool anyway that it landed on it. So yeah, Rosetta has completed its mission, providing astronomers with really useful information for comets. One of the biggest findings being the detection of organic molecules and amino acids, which are important for giving life, life-giving elements. And so this suggests that comets may have played a significant role in delivering these life-giving elements to Earth. And it's estimated that scientists have only analyzed a mere 5% of the data collected by Rosetta, and they'll be busy understanding the rest of it for many years to come. So Rosetta has now found its final resting place. It crash landed just on September 30th, and will remain on 67P for the foreseeable future.
All right. Boyajian's star, I hope I'm pronouncing her name correctly. You might remember this one. This has been in the news for the last year. Dr. Jeff Silverman has been very happy to talk about this several times previously in Astronomy in the News. It continues to be really, really, really weird. So this is the star you might have heard that people suggested alien megastructures. Of course, we're not really quite sure about that, but we really don't understand what is going on with the star. So the most recent research, Ben Montet of the University of Chicago, shown down here in the corner, he's been monitoring this star for the last several years, looking at data going back to about 2010, and found that this, so you might have remembered about 6 months ago we figured out that this star has been dimming slowly over the past 100 years or so. Ben discovered that in the last 5 years or so, it's been dimming at a rate of about 1% a year, which is pretty unusual for an astronomical object. On top of that, in a 6-month period in 2012, its brightness suddenly dipped by an additional 2%. So one of the problems with this, one of the theories that was suggested for why the star is doing such weird things is that perhaps there's some sort of swarm of comets or a comet that broke up or something like that, that, you know, all those little bits and pieces have been passing in front of the star. And these long-term brightness changes and this really sudden dip in brightness really runs counter to those ideas. So right now, the best idea of what is going on with the star is we have no idea. So alien
often is the
megastructures,
case with science.
alien megastructures is still a possibility. All right.
All right, so new observations made by the VISTA Infrared Survey Telescope at the European Southern Observatory in Chile have found a dozen RR Lyrae variable stars in the heart of our own Milky Way. Jesus, the very sensitive clicker. So here in this image are other variables, not RR Lyraes. Most notably, many of you may have heard of Cepheid variables, which are much brighter than RR Lyrae stars. So RR Lyrae are old, red, and dim stars, but like Cepheid variables, have these very even periods of pulsation, of brightening and dimming. So if we zoom in even further into the Milky Way, we see two. Oh, do we see two? There were circles around them, and now. Well,
everybody knows what they are.
Well,
right?
They're very dim. They show up on the computer. If anyone can see a red, oh, there's one, and there's another one there. Okay, so they're really, really dim. But what makes all of this exciting is that our Lyrae stars are typically found in okay, I'm just not going to touch it. They're typically found in populations that are more than 100 billion years old. In globular clusters, which are groups of old stars that typically lie in the far outer regions of the halo of galaxies. And so finding these stars in the heart of our Milky Way suggests that the bulge of our galaxy was created by mergers of these globular clusters, and this has helped put in constraints on the theories of how the Milky Way is formed, whereas a competing theory is that gas quickly accreted into the Milky Way to form the Milky Way rather than these mergers. So here you go. I don't want to touch that.
I will be careful with it. All right. Raghvendra Sahai. Somehow I couldn't memorize that name. Jet Propulsion Laboratory discovered blobs of hot gas shooting out of a star. So these blobs we've got an artist illustration of what's going on here. The blobs are the blue things kind of flying out to the edge. Each of these blobs are about the mass of Mars. So these are really, really, really big blobs of gas. The star itself is a red giant. So it's a star, probably a couple times the mass of our sun that's getting towards the end of its life. There's no real explanation of why a star like this would be shooting out giant Mars-sized blobs. However, he was looking at this, he measured it over a period of time and found that these blobs are showing up every 8.5 years, somewhat regularly. So his speculation is that there is a star shown here. Actually, hopefully I won't click the wrong thing. We've got so here's the red giant star. Nearing the end of its life. This little bluish small thing is a white dwarf, and he's proposing that there's a small white dwarf, a small old star, that is orbiting the star in a very elliptical orbit, and it's so elliptical that at the closest point that they are, it enters into the very edge, into the very atmosphere of the larger star, and sucks up a bunch of material from the star and sends it shooting out into space. So these blobs are moving fast. They're moving at about 400,000 miles per hour. To put that in context, it would take about half an hour for that blob to move from the Earth to the moon. It took Apollo 11 about 4 days to do the same thing. So moving pretty darn fast. So this seems a pretty plausible explanation, and about the only way that we could explain something that's so big and so fast is by invoking another star or something like this that managed to interfere.
All right. So this one's a good one. The number of galaxies that we thought to exist in the universe turns out to be wrong by about a factor of 10.
Only a little bit off.
Which is kind of big. So a team of international astronomers led by Dr. Christopher Consolence, shown here, at the University of Nottingham have found that this factor is off. And so the team created this 3D map of the known universe. Oh, I swear I didn't even touch it. Relying on Hubble deep field images, which map the 100 to 200 billion galaxies that we currently, or before this, were thought to exist. And then by incorporating new mathematical models to calculate where other galaxies that we just can't see because they're too faint and our telescopes aren't sensitive enough to find them, the group found that we're missing around 90% of the galaxies in the universe. And so belief is that the early universe contained many more galaxies than there are today, most of these being these small faint dwarf galaxies that we can't see. And then these merged together as the universe evolved to create the larger but less abundant galaxies that we see today.
All right, and finally, Black Hole Mama, Dr. Noyola was just talking about supermass black holes, small mass black holes. We've finally found perhaps an intermediate black hole, so something right at the very edge. Daxing Lin at the University of New Hampshire was looking at some X-ray data. So what we have here is an X-ray image of one particular spot in the sky. It's relatively bright in X-rays, looks pretty boring, just big blue blob. But X-rays, as Dr. Noyola pointed out, X-rays tend to come from black holes. And sure enough, there is a galaxy that has a really bright spot out at the edge, also found in optical light looking back at old Hubble data. All of this picture put together seems to suggest a black hole of about 100,000 times the mass of our sun. So somewhere between those giant million and billion sized solar mass black holes and those smaller 10, 20, 30, 100 solar mass black holes. What we suspect is going on here is there's probably a smaller galaxy that got absorbed by this larger galaxy, and the black hole from that smaller galaxy is still around. It hasn't fallen into the center. Nothing else has happened to it. It's just out there. If you were here for my talk last month, I talked about how there's a possibility that black holes, not necessarily quite this size, but black holes might explain dark matter. This black hole would be dark matter, except for the moment that we can see it. However, we could see it 10 years ago. So all of the data that I'm showing you here, both this X-ray image and this optical image, happened in about 2002 to 2004. When he went back and looked at newer data, it was gone. So what we suspect is happening is that whatever this black hole was, it was probably swallowing a star when we happened to look at it a decade ago. And now we can't see it anymore. So we were extremely fortuitous to have happened to see it at just the right time. If we would have waited until now to see it, it would already be gone. But this is very promising for the future of dark matter and our understanding of the formation of smaller galaxies. All right, that is all we have for Astronomy on Tap for this month. Thank you very much.
Thank you.